All right, now we're going to calculate the area of regular polygons. So what's a regular polygon? That's a polygon, in other words, a multi-sided shape where each interior angle is the same, where all angles inside of the polygon are congruent. So like in a square, all 4 angles are 90 degrees. Right? Inside of a pentagon, all 5 angles are going to be congruent. So how many degrees are there in a pentagon? Well, there's 540 total inside of a pentagon. Each one of them is the same, so I can divide by 5 to figure out how big each one is, and that's going to be 108. So each one of these is 108 degrees if this is a regular polygon. Not 180. What about a hexagon? How many degrees total in a hexagon? 720. I would have to divide this one by 6. Right, because there's 1, 2, 3, 4, 5, 6 angles inside of a hexagon. So 720 divided by 6, I believe that's 120. So each one of these angles in here, 120 degrees. That's if it's a regular pentagon or hexagon. What does that have to do with anything? Well, we're talking about area. So what I want to know is, let's say I have this pentagon right here and I want to know what the area of it is. What we're going to end up doing is we're going to end up creating 5 triangles. We're going to figure out the area of each of those 5 triangles, and then we're going to add them together. That's how this basically works. So to figure out the area of one triangle, I need 2 things. I need a base, which would be this side up here, and I need a height. In other words, from the highest point, it's not really the highest point on this triangle because it's kind of pointing down. Basically the distance from the base to the furthest point away, so I would need that right there. Okay. When we're solving for the area of a regular polygon, what I called the height up here, we're actually going to call the apothem, which is going to be the height of a triangle Okay, so there's one apothem, and if I draw another triangle down here, then this right here would be another apothem. All apothems inside of the same regular polygon are going to be equal. So all I really need to do, I don't need to do the same thing 5 times, because each of these 5 triangles I draw should be exactly the same. So what I would actually need to do, figure out the area of this triangle right here, or this triangle up here, and then multiply it by 5, right? Because eventually I would have 1, 2, 3, 4, 5 triangles inside of this pentagon. So I don't need to do it 5 separate times. I can do it one time and then multiply it by 5. Okay, and so that's sort of what this formula right here is saying. Use this formula right here, base times height divided by 2, to figure out the area of this triangle, then multiply it by n, which is the number of triangles that I could fit into this pentagon, right? So n is not only the number of triangles I could fit in the pentagon, but basically the number of sides of the polygon. So the pentagon would have 5 sides, so I would take, what's the base times height of this triangle, multiply it by 5. That would tell me the area. What does that actually look like when we use it? Okay, well here's a pentagon-shaped hot tub, apparently. And we want to know what the area of the cover of the hot tub is. So if I wanted to, I could divide the cover of this hot tub into 5 separate triangles, right? 1, 2, 3, 4, and 5. But I don't need to do that if I can calculate the area of this triangle right down here, I can just multiply that by 5 and it'll tell me the area of the cover. So it's pretty simple. If I want the area of a triangle, I just do base times height, and it gave me both of those here. Base times height divided by 2, I should say. So the area of this triangle is going to be 1.7 times 2.5 divided by 2. But what I'm going to do, since I want to know the area of this whole entire cover, is I'm going to multiply this whole thing by 5 because there are 1, 2, 3, 4, 5 sides to the shape that I'm looking at the area of. Okay. Area equals, what's 1.7 times 2.5? 4.25 divided by 2, and it's still times 5. Okay. 4.5 divided by 2 is that. So I would have area equals 2.125 times 5. $10.625 is the area of the cover for this hot tub, 10.25 square feet. Okay, I can do it with a triangle also. In other words, if I knew where the center of this triangle was, I could break it up into 3 smaller triangles. What I need, though, is not only sort of this base out here, which it tells me is 4, I would also need this height, or the apothem. The problem is I'm going to have to do a little bit of math. That's not a problem. It's just the next thing that we have to do. So if each side, so I didn't say it here, but I can assume from the picture that this is an equilateral triangle, meaning all 3 sides are 4 feet. So if I draw this triangle, that means that this part is 2 and this part is 2, right? If the whole thing is 4 feet long, then half of it would be 2. All right, so I have a triangle here, a right triangle, and I need to know this side right here. In other words, the height of this triangle. If I can figure out the height of this triangle, well, then it's going to be pretty simple, right? I want base times height divided by 2. The base I already know is 4, right, because all 3 sides of this triangle are 4. So now I just need to know this one, which is the height. So I'm just going to use the Pythagorean theorem. I know one of the sides is 2, the other side is x, and then this third side is 4. Well, that 4-foot side is going to be the hypotenuse. So 4 squared is going to equal 2 squared plus x squared. 4 squared is 16, 2 squared is 4. If I subtract 4 from both sides, I would get x squared equals 12. I would then need to take the square root of both sides. X would be equal to the square root of 12, which is 3.46. So now, I figured out what the height of this triangle is. It's this 3.46. So up in my formula here, instead of writing h, I can put 3.46. So now I have a formula that I can use to solve for the area of this triangle. The area is 4 times 3.46, and that divided by 2. So 6.93. And that's square feet. That's the area of this triangle. 3b is a little bit different. Now I have a square, and the only information I have about that square is that if I draw a line from the center of the square out to one of the vertices or one of the angles, it's 7 centimeters. There's 2 or 3 ways that we could solve this one. I think the easiest one is going to be to do this. If this line right here is 7 centimeters, then any other line that I draw from the center out to a vertex or an angle would be also 7. So in other words, if I go from one corner to the opposite corner within this square, it's 14 centimeters. Okay, so if I redraw the square, just to clear up the clutter a little bit, that's 14. So now what I have is a right triangle. I have two right triangles really that are exactly the same. So if I can figure out the area inside one of these two right triangles, I can just double it and it'll give me the area of the whole square. Okay, well, how am I going to do that? Well, if I look at this top triangle, 14 is the hypotenuse, right? 14 is the hypotenuse. But what would go on the other side? Because I have an A and a B and I don't know either one of them. What I do know about them is that because this is a square, all four sides are the same. So instead of saying A squared plus B squared over here, I know that A and B are the same. So I can say A squared plus A squared on the other side, right? Because if this one, whatever this one is, it's going to be the same as this because in a square all four sides are the same. So what does that do for me? Well, 14 squared is 196. On the other side, if I have an A squared and then another A squared, I would have 2A squared, right? I have two A squareds basically. I want to get A by itself. Before I take the square root, I want to get rid of this 2 coefficient out in front. The way I'm going to do that is to divide. So I would have A squared equals 196 divided by 2, which is 98. Now I need to take the square root of both sides. So A square root of 98, which is, let's call that 9.9. Alright, so I haven't solved the problem yet, but what I know is basically that each one of these sides is 9.9 units long. There's two ways we could go here. There's the way the textbook probably wants me to go, and then there's the easier way. So I'm going to show you both. Here's the easy way. Once I know one side of a square, I literally just square it to figure out the area of the square. So the area of the square, since I know this side is 9.9, I know that side would be 9.9. If I want to know the area, I would just do 9.9 squared, right? 9.9 squared is 98.01. Oops. So I'm just telling you there's this easy way to do it. Then there's the more difficult way that they probably want me to show you. So 98.01 square centimeters. I know that's correct, and so I'm going to show the other way. It should give me an answer approximately equal to 98.01. Okay, like what I was saying before is what I want to do is figure out what the area of like this top triangle is, and then if I double it, it'll give me the area of the whole square. If I look at that top triangle, again, I know all four sides are 9.9. So the base is going to be 9.9. The height is going to be 9.9. So I'm going to have 9.9 times 9.9 divided by 2, right? Area equals base times height divided by 2. Well, I already figured out that 9.9 times 9.9 is 98.01. Divide that by 2, and it's about, we'll just call it 49. Okay, but what I said before is once I know the area of this triangle, I got to double it to get the area of the other triangle, or to get the area of the whole square. So I know this is 49, that's going to be 49, and I mean you can see this probably what's going to happen. If I double 49, it's just going to get me back to 98. And so either way I do it, I come out with an answer that's about 98. Look for shortcuts when you can. Really, I didn't have to use anything I learned today to solve this one. I just needed to use the Pythagorean theorem and a little bit of logic. 3C is the best example of what you're going to have to do on the test. So I'm going to go a little bit slower, and there's more involved here. So I kind of cleared a little bit of space for myself. You don't have to do that on your note taker. Make sure you pay attention on this one though, because it's more complicated than the others. And as I said, it's more similar to the ones that you're going to have to do on a test. And so I have this octagon here, kind of looks like a stop sign. The only thing it gives me is the apothem, which is 8 inches. So basically if I drew, that's not very good. If I were to draw a triangle like this in this hexagon, the only thing I have is the apothem, right? The distance from the center out to basically the middle of one of the sides of the octagon. Okay, so that's not much to start with, but believe it or not, we're going to be able to calculate the area of this octagon with just that information. We're going to have to use a little bit of trigonometry and the Pythagorean theorem to do it, though. I'm going to kind of just redraw this triangle by itself up here. So I know that this right here is 8. What I need to know is this base down here, right? Because once I know the apothem and the base, there's a pretty easy formula to use. It's just 1/2 a times p, and p just being the perimeter of the octagon. So I'm working towards getting the information to use this formula up here, but I got to do a couple of things first. Okay, I need to know the length of this bottom side. Well, what the apothem does is sort of create 2 right triangles. If I want to know this side down here, first I'm going to have to figure out what just this piece of the line is. Okay, so all I can do to start with is figure out what that is. To do that, I'm going to need to use trig because I only know one side of my triangle. Okay, so I can't use the Pythagorean theorem yet because I only know one side, but I can figure out what this angle right here is. How do I do that? Well, I know that if I were to make a circle around this octagon, there would be 360 degrees in it. And this one triangle is basically 1/8 of the way around that whole circle, right? There's 8 sides to this octagon. That means that one of these triangles covers 1/8 of the distance in degrees around the whole octagon. In other words, if I do 360 divided by 8, that'll tell me what this angle, or like this angle right here is. So 360 divided by 8 is 45. So 45 degrees is this angle right here, the whole thing. But because the triangle I'm working with is this one, this angle that I want to use up here is going to be half of 45. Right? I'm sort of cutting that 45-degree angle into 2 equal parts. So if I go one step further and I just isolate just the triangle that I'm using, I know this side is 5, this is the one that I want to know. This angle right here is half of 45, which is 22.5 degrees. Okay, so I said we're going to use trig, so let's do it. What I want to know is this side down here. From my 22.5 degree angle, that y is an opposite. So I know the opposite is y. What is this 8? Well, this 8 is an adjacent side. When I have opposite and adjacent, I use tangent. So the tangent of my 22.5 degree angle is y over 8, right? Tangent is opposite over adjacent. So what is the tangent of 22.5? 0.41. And that's equal to y over 8. Now I'm going to multiply both sides by 8. So y is going to be equal to 8 times 0.41. So 3.1. In other words, this piece, or like this part right here, is 3.1. What I want to know, what I need to know is like this whole thing though. So if that part's 3.1, this part would be 3.1, meaning each side of this octagon would be 6.2, right? 3.1 plus 3.1 is 6.2. Now I basically have almost everything I need to figure out the area, right? I know the apothem, so if I'm going to use this formula right here, the area is equal to 1/2 of the apothem, which I knew right from the beginning was 8. Now I just need the perimeter of the entire octagon. To figure out the perimeter, it's 8 times, right, because there's 8 sides. 1, 2, 3, 4, 5, 6, 7, 8 sides. Each one of those sides is 6.2 inches long. (49.6) is the perimeter. So I'm basically done. I just have to run these numbers through a calculator. So the area of this octagon is 1/2, which is the same thing as 0.5 times 8 times 49.6. So 0.5 times 8 times 49.6. And the area of this octagon with an apothem of 8 inches is 198.4 square inches.